All right, so how to hack your sci-fi armor, adding high tech to your cosplay. So let me tell you what this panel is going to be about. This panel is going to be about the journey that I've been on to build high tech Iron Man armor. This is not really your beginner class, so we're gonna take it all the way from where I started, what I produced a few years ago, to where I am today. I'm going to go through what I've been working on for the past, I don't know how many years at this point, 6 or 7 years, as well as really what I've been doing in the past year or so. I haven't published much content to my YouTube channel, and instead I have been focusing on just getting the work done because every time I make a video, I'm not coding. All right, so this is how do we turn that into that? How are we going to get as close as possible to actual Iron Man technology? About me real quick. I'm a content creator, cosplayer, software developer, maker, teacher and coach, father, husband, all these things. What did I build? So this is the first video. If you've been to my panel or seen my channel, this is old hat. I'm not going to spend a whole lot of time on it. And that's the helmet I built. This is the Mark I that is sitting down here on the table. It's currently not connected, but I wanted to bring it to show it to you in person. And this is what it looks like inside the helmet. This is a walk around that I did a few years back. So it had object recognition. It had basically everything you saw in Iron Man 1, it pretty much did. Missing one feature that we'll talk about later. All right, I'm not actually going to play this video because I don't have audio hooked up, and plus I covered this in my other panel, which I'll be posting to my YouTube channel. So I've got a Friday AI assistant in the helmet as well. It not only answers questions like any other LLM would, but it also controls various elements of the HUD and the suit and all that good stuff.
Will it lie to you?
Yes, but not intentionally. It will hallucinate to me all day long. So I'm gonna kind of, there's no particular order to this. There's a lot of technology here. I'm just gonna do my best to go through it. Starting with the Mark I and what it originally was. So it's an NVIDIA Jetson Orin NX. That wasn't the original hardware. It was originally an Xavier, if that makes any difference to you at all. But this current one has 8 ARM cores, 16 gigs of RAM, a 1024 NVIDIA GPU in it. It's got low latency audio and video, the sensor integration. I need a computer this powerful to do everything this helmet does. So when people ask me, can I do this on a Raspberry Pi? The answer is yes, but not like this. So I've actually done some work porting some of this software to Raspberry Pi. So some of that code is available that I've already published because I know people wanted it. So you just can't do it all at the same time like you can with this system. All right, so a little bit more about the original hardware. It's got dual 1440 by 1440 displays, run at 120 hertz. The dual cameras would do 1080p at 60 hertz. And then there's a microcontroller in the top of the helmet that handles all of my sensor gathering. There was a little sensor board in there. You can see that here on the right side. That little red board in the top, it blends in with the helmet. There's a little microcontroller board there. And that has a teensy microcontroller, GPS, 9 DOF sensor, otherwise known as an IMU, an inertial measurement unit. And then it also has a humidity and temperature sensor built into the helmet. All right, so how do we go from the Mark I to the Mark II, which is the new, freshly 3D printed helmet down here? All right, so we had some shortcomings, and we had a wish list that came out of the first helmet. The size of the helmet, it's always been a problem. It's got to be a little bit bigger. We have this thing called optics that we have to deal with. You can't take a screen and put it right in front of your eyes and be able to see what's going on. You have to do something optically to be able to see that screen. The cameras are visible. People like to comment on that the Iron Man looks a bit cross-eyed because the cameras are right there visible at the center of the helmet. And the faceplate doesn't open. The original version, the faceplate doesn't open. You do have optics and stuff in the way, and it makes it more difficult to get the faceplate to do what you want it to. I did actually try in the original one, ran out of time. I'm not a mechanical engineer, so it takes me a little bit longer to figure that kind of stuff out. And then the wish list. So we need better sensors. That first set, the sensors were a little dated compared to what was available on the market. Better battery monitoring. The original version, I had no way to see what was going on with the battery. We'll talk a bit more about it. I always wanted night vision in this helmet. You've got high-tech cameras. You should be able to do something like night vision, right? A modem would be nice because as it was a tethered device. I'd have to turn the hotspot on in my pocket and then it would be tethered to me. Which it works, but as you know, tethering isn't always the most reliable thing in the world. Cell phone calls would be nice. And a local AI assistant so that you don't have to be connected to the internet for everything on your suit to work. All right, so let's talk about the AI assistant. These were supposed to pop up one at a time, not all at once. But anyway, so the new AI assistant that is available now in the latest version of my helmet supports both a cloud LLM, so something like OpenAI, as well as a local LLM. It is running a local large language model at about 4 gigs of memory. And that is either Quinn or Gemma. Those are my 2 favorites currently. It has live switching between the 2, so it can tell if it has an internet connection. If it has an internet connection, it will use the remote one, and if it does not, it will use the local one. The purpose of that is the local one is usually quite a bit dumber than the cloud one, just due to the size of the model. And so if I can use the cloud one, I actually prefer to, but you don't be without your assistant, so we have the local. Local speech to text and text to speech. Basically, you can speak to my AI assistant. It will speak back to you. Let's see if she's on. Okay, Riley, are you there?
Yes, I'm here, Vachakal. You know what I mean.
So it's still running the personality from the previous demo. So if you were here the other day, so now she's a Klingon. And so the last panel I did, which I will be posting onto the YouTube channel, we played with the AI assistant's personality. So this AI assistant currently thinks that she's a Klingon. It has what am I looking at, AI assistant vision. It will take a picture of what it's looking at, and it will send that to the AI, and it can interpret what is going on at the time. It is interruptible, meaning I can, at any point in time while it's speaking, I can interrupt it. It knows the difference between whether I'm simply interrupting it because I'm talking and I just need a minute, or whether I am asking it to stop doing something or to do something different, and it can interpret the difference just by whether it receives a wake word during that period of time. As I just talked about, it has a customizable personality and voice, and now the AI I'm working on is learning how to operate the armor and the technology that it's connected to, and I'm training it to run commands on the suit. So if I ask it to do something that is a function of the armor, it can do something with the armor, change the display, that kind of thing. So this is the new one. So the upgraded helmet sensor controller board. Let me talk about it real quick. This is a custom PCB that I designed. It is running a bunch of other custom PCBs by other companies. The top 2 are Adafruit components. We're going to talk about them in a minute. They are both environmental sensors. The little board in the center is an ESP32S3 microcontroller. And then the bottom 2 are the new inertial measurement unit. The IMU is on the left. And this is a new up-to-date GPS on the right, which has much better ability to get GPS signals in hard-to-reach locations. This is just, again, it's a little breakout board that I designed. You can see it also has connectors here on the right for things like the motors, the servos that are in the helmet, as well as lights, and a push button in case I want to open and close the helmet manually. We'll do a quick demo. There you go. So the new helmet opens. That was one of our check boxes. Doesn't open widely, because again, there are things in the way, but I was able to figure it out mechanically and make that helmet opening process work. So again, new powerful microcontroller in the helmet. We've got a better GPS, a better inertial measurement unit. It now has new environmental sensors. That's supposed to be air quality, which you probably figured out. Air quality sensor, That's a gas sensor. Basically, it can detect the particulates in the air. It can tell me what the current air quality is. We'll talk about that in a minute. And then it also can detect CO2. You're wearing a helmet, so you're breathing in this helmet. I'd like to know, am I building up CO2? Is it, and then it also has temperature and humidity just as before, but a little bit more accurate. All of this, like I said, on the custom PCB. All of this is open source. PCB will be available. I haven't made it available yet. No one's asked for it. But if you wanted to build one yourself, you could have some of these made. New software from the ground up. I rewrote the helmet software altogether. If you're familiar with any software design, it is running free RTOS on top of the Arduino IDE. I'm using Arduino mainly, number one, for accessibility so that people can use it and can access it. It's easier than using something like the Espressive one for the ESP32. Plus, it gives us access to other microcontrollers. So if you wanted to do it with a different chip other than an ESP32, you could easily port it to another microcontroller. And the new one is all multi-threaded. Each part of the system has its own process. Makes it easy to write new processes for it because it's easy to include and exclude the different components, as well as it's really good for performance because this is a multi-core processor running on the helmet, and it can do, I can assign it to different processors. All right, so this leads all into a demo. All right, so this is the new helmet. So you can see this is a live feed. If I wiggle the helmet here a little bit, you can see that it is working. You know what? I didn't do that. I did not enable the sensors.
Your HUD is shutting down.
She knows what's going on. She's paying attention to the systems and the processes. You see again, she's paying attention to the processes. There's a whole inter-process communication system I've got built in here where they're speaking over a protocol called MQTT.
Your HUD is now online, boss. Helmet connected.
All right, and you'll notice there's a little flicker in here. I've got a new hardware set up, and some of the cables need shielding better, so that's where that flicker is coming from. There's a little bit of shielding issue on these little wires that go to the cameras. All right, so let me show you what we've got here. When I was talking about the AI assistant, you'll know on the upper right side, there's this little LED with Friday underneath it. You'll see that it keeps blinking on and off. What that is I found that was when I was in the helmet, I couldn't tell what the AI state was, whether she had heard me, whether she's processing. And that little LED now tells me what she is doing. If it's green, it's waiting. If it's purple, it's listening. If it's red, it's processing. And so now I'm not worried that she's hung up. I don't know if I told her something and she's still thinking about it. It gives me a much better understanding of the state of the AI. And again, that's dynamic. You can name your AI assistant whatever you like. You can change the wait word. And that little Friday that's underneath it reflects whatever you've called your AI. All right, so you'll see this is the original HUD. It does have the leveling. When you tilt the helmet, you get a change on level there. It's got north, south, east, west. The compass is up top. It has the altitude. You'll notice since the helmet is shifted a little bit, you see that the tilt is not perfectly level. We're about 16 degrees. That hasn't been calibrated, but that's what that does. The GPS, again, we've got a big building above us. The GPS is not accurate, but that is a GPS. In the lower right, using Google Maps and live data. All right, so, and then the little suit temperature, you've got the humidity and temperature that is inside the helmet, as well as the CPU, memory, fan, temperature information. And that's for the board itself here. All right, battery. So before this project, I'd never built a battery from scratch, and now I have. So this is a custom battery pack that I built just for a wearable suit of armor. This is the big boy. There's going to be a smaller boy that's coming later because this one's pretty heavy. So this one I designed previously, well, going back to where I started, I was originally running the entire thing off of a large laptop battery charger that you could, I could put in a pouch and wear. that presented a lot of problems, because if I was wearing that, I could not view how much battery I had left. I'd have to ask my wife, like, can you look and see what the percentage is and how long do I have? I didn't have any of that information on me. I didn't know how long I'd be able to wear it. Plus, it only lasted so long. So I needed a new solution to the problem. So I actually worked with an OpenAI assistant, a ChatGPT assistant, to help me design this battery. Because I said I needed to last this long, I needed to be safe, and it did a very good job of going back and forth, and it taught me some things, and I was able to tweak it, and we worked back and forth. Again, I'm not a battery engineer. I've never built one of these before, and it was really able to help walk through the process. And then I watched a bunch of YouTube videos of people actually building these things and learning how this works. So it came up with these cells. These are some very high capacity cells. These are Samsung cells, and this whole battery pack is a 10 amp pack running at 14.4 volts nominally. And it was designed originally to run, I wanted 4 hours out of the suit. That's what I was going for. But this computer right here pulls almost 30 watts sometimes. And so that's quite a bit of power to run for a long period of time. And so I designed it for 4 hours at 28.1 watts, which is the power profile I have on the system. That's about the most it will pull. I find when playing with it at home that it'll actually run closer to 6 hours, which is why I'm going to build a smaller version of the pack, because I'm usually not pulling 28 watts. I'm usually pulling around 22 watts is what I found. All right, so again, the most important parts of this battery pack for me was to be able to monitor it, as well as to be able for it to be safe, because I'm wearing it. I'm wearing lithium batteries. I don't want it to catch fire and not be able to get out of the suit. Sounds like a horrible day. And so again, it was built with safety in mind, and so it has what's called a battery management system on it. It's got a smart BMS on it. That battery management system takes care of everything: charge, discharge, overvolting, battery cutoff, cell balancing, temperature. So that is the first line of defense to make sure that nothing goes wrong, because that is monitoring what is going on in the battery. But then, just to be doubly safe, and this was again suggested by the AI assistant, it has both a thermal fuse as well as a traditional fuse on there. So if something goes haywire and it decides to pull over 15 amps, don't know how that would happen, but if it did, it would pop that fuse. It also has a 77 degrees Celsius thermal fuse on here, so if it heats up beyond a certain point, it would pop that fuse as well. Stop, turn everything off, and everything would still be safe. Now, let's switch back over to this, and I will show you what that looks like. So, one of the things that I had to do when I was designing this was I realized one screen wasn't enough. You've got a lot of data now going to this suit, so one HUD isn't enough. We need multiple HUDs. And so that's what you have here, is multiple HUDs. So as we switch around, you can see different systems, and you can just switch between them. I can even ask Friday to switch these HUDs verbally for me, and she will switch them. So I can say, switch to my environmental HUD or switch to my armor HUD, and it will switch back and forth between these. Again, this is a live feed from the battery. This battery, like I said, the battery management system I have on here actually has a serial communications that is going directly to one of the serial ports on the system. And so this is live data coming off of that. This is a very modular system. And so the battery management process that's running on the computer is a whole separate process that reads the battery management constantly, reports that to the HUD for processing, and so it's isolated, and so I always have this information. You see what's up here? It has the current charge of the battery, which is 55%, which has this nice little graphical battery meter as well as it's doing a. You'll notice that number keeps changing. It's because it's constantly trying to evaluate how much power is it pulling and how much power is available. And so this is a real-time battery monitoring system that will say exactly how much time you have left, just according to power curves of batteries. The battery management system is pretty sophisticated. It actually takes into account the technology of the battery, whether it's lithium ion or lithium polymer or whatever type of battery you're using. That's all built into the battery management system. You tell it what kind of battery you're using, and it has all those drain curves built into the system. And so that is as accurate as I could come up with for like this 3.5 hours. That should be pretty close to 3.5 hours. It's not just a linear curve. We actually map it to the type of battery you're using. And again, current voltage is almost 15 volts. 1.6 amps is what we're currently pulling. And that's the current voltage. So that is actually what this computer is consuming right now, and that is real-time data coming from this custom board that's on here that I'm using. I'll talk a bit about it as well. And then I did talk about the sensors already, so let's go back to that screen. So this one, you'll notice on the upper left now I have the sensor information coming off the helmet, humidity, do some calculation for things like dew point, and the heat index, the air quality in this room. It's average. It's average air quality. We got about a 60 there. So that is the parts per billion of the gas sensor, and the parts per million of CO2 in the room. And then it tells me why is the air quality 60. It says it's mainly from human respiration. So the CO2 in the room is relatively high. So that's what that comes from. And it actually is reading those informations to actually determine why you should you be concerned. Where's the air quality concerns coming from? So if I switch to the screen, I actually know what it means. Is there carbon monoxide or something? I don't know what all this does. All right, let's talk about the modem, because that was a big feature for me that I really wanted to put on here was the modem. And you're looking at it there, that little board sticking out there is the modem on this board here. So as requirements, I wanted it to be fast enough, of course, to get to the LLMs, which that doesn't require much. You're mainly just sending text back and forth. But I also wanted to be able to be able to live stream directly from the suit, which this will stream directly to YouTube from the helmet. I've used that at home. I've tried it a couple of times out and about, but it's difficult still to get quite enough bandwidth, so I'm still working on that. It's a quality versus bandwidth sort of issue. More than the system. The system doesn't have any problems, so it's hardwired, it screens all day. And then I wanted to be able to make voice calls. I was telling you that there was one feature from that first Iron Man movie that I did not have in that first helmet, and that was being able to make a phone call from the helmet. And I should be able to do that with this modem. This modem not only has data access, but it also has texting, and it has voice access. I just haven't written the code yet. So that should all be available when I get this modem. And again, right now this is connected via the modem, so all of this is working using this modem, and it has really good bandwidth here, I find, which is surprising in this room. So the cameras, so many decisions have trade-offs, right? You can have this, but you can't have that. If I put this piece of hardware in here, then it'll be able to do this now, but now I can't do that anymore. And that was the deal with the camera. So the original helmet here, again, you can see the cameras, and that was the decision that I had to make in that first version. I can hide cameras, and that's what I'm going to show you in this new one. But the cameras in this helmet are better, right? They're higher quality. They have higher resolution. They have better optics. That's why I chose them. If you watch that first video on my YouTube channel and see that live recording that I made from the helmet, the quality of that recording is very good. But if I go to hidden cameras, there's going to be trade-offs. So the no-show cameras is a downgrade graphically. So we're going from an IMX417, which these are Sony sensors, Sony camera sensors. We go from a 417 to a 219. The 219 is basically the Raspberry Pi camera that many of you may be familiar with. We now can't do 1080p anymore because the sensor doesn't support it. We have to do 720p, particularly if we want to stay at these 60 hertz, which is much better graphically if you're walking around live in something. And the lower quality lens. That lens on that 417 is really nice. The one on the Raspberry Pi, not so good. And then, again, I said I wanted night vision. So if I do night vision, I have to have what's called a no IR camera. It doesn't have an IR filter on it anymore, because that's how you view at night, is through other spectrums. And so you have to take off the IR filter, which now everything has a pink hue to it, which is why you were seeing the pink hue in that. That's not the natural state of the original version. So if I switch over, you see there. And if we look at the helmet down here, we've got two. You'll notice that they're not even the same, and I'll tell you why. So again, both of these are the no IR cameras. Let me show you real quick something. One person, I need one person. You can stand up real quick. Stand up right in front of that suit, that helmet. Just so that, there you go. All right, so this, no one sees anything. See that? So this is a IR flashlight. So that's why you're seeing it on him, but you guys aren't seeing it with your naked eye. So just wanted to demo the night vision portion. It looks really good in the dark, because this thing is really bright. That's a nice feature, but again, now everything has a pink hue to it. I am working on, since again I have a powerful graphics system here, I'm working on some filters to try to tone down that pink a little bit. But when you tone down one color, you're kind of doing it artificially. You're not inventing more colors that aren't there. But I can tone it down a little bit. Again, you've got two different views here. You've got the one on the left and the one on the right. The one on the left, you'll notice you can't see the camera anymore. So that was one of my goals. It has actually a two-way mirror in front of it. But you'll see the one on your right is a lot clearer than the one on the left. So you put the two-way mirror over it, you lose a little bit of visibility, and you lose a little bit of brightness by putting that over it. And so again, the trade-offs. Now I've achieved the goal of having an Iron Man helmet that you can no longer see the cameras in, but I've had trade-offs for it. And so you'll see there's a two-way mirror on this one, and there's an LED ring around it, which is also why there's not only a pink hue, but a blue hue, because now you want LEDs around your light. And so now you have this artificially colored version of what you originally started with. What I call the elephant in the room was the size of the helmet and the ability to also open it up. So this helmet I built right before I came. This is brand new. I had all this figured out. I knew how I was going to build it. I'd already designed all of the inner workings. It's got all of the motorization. Everything in this helmet was custom designed for this. But this first time I had actually put the whole thing together. So I tried a new flexible display. And you see that here on the right. It is a flexible OLED display. It does work just fine. You can bend it and flex it, but it doesn't like being bent and flexed in certain parts of it. The part that you need to bend and flex, which is the part that you want to curve around the backside, not the part that you see. And this is the second one I've broken. So, and this is a $200 screen. So it really, it sucks, but that is part of playing in this domain, playing with things that people aren't doing before. There's no prior art to this. And so I'm trying to figure out how to do it. I'm trying to figure out how to put it in front of your face. Like I said, it works really well. I even got the optics to work with a curved display around the front of the mask, but it is not working well right now. And I have to decide if we're going to try a third time, because if I did, I'm probably going to have to redesign that mounting, see if I can get it all to fit, get it to actually not have to bend in certain places. Do I have room in there? If it doesn't bend where I wanted it to bend, it becomes a real problem. Again, limited space. I don't have, particularly if you want it to open, if I wanted to leave it closed, I'd have more options. Because if you left it closed, you could just keep it going around the side of the helmet, no big deal. But if you want it to open, it has to all fit in that faceplate. So, plan B, or plan C, whichever one I'm on at this point, so is to go with something off the shelf. And there's actually several good reasons for me to do this. Number one, this has superior optics to what I'm able to put in this helmet. This helmet, obviously, I'm just using a couple of off-the-shelf lenses. It's what I can get a hold of. Same thing with the displays. I'm having to buy these from AliExpress. Occasionally you'll find them on Amazon or something, but I'm having to order these from overseas. And I only have whatever's available on that website. I can't just call up manufacturers and say, hey, can you give me a 4K display? I'm building a helmet in my garage. And so what I'm thinking of is just basically let's build something off the shelf. This is superior. It has superior optics. They've spent lots of time, lots of money, lots of resources on having just about the best optics in the industry. It is the smallest VR headset that you can get your hands on. This thing is like 200 to 300 grams, I believe, somewhere in that range. Very lightweight. They have, each eye is like 2000 by 2000 resolution, 2100 by 2100, something like that. So higher resolution displays than I can get my hands on to build myself. And they are strong supporters of the modding community. They actually have a 3D model that's available that I can download, and I actually meant to put that in here, but I've actually done a little bit of the pre-work of seeing would this fit in my helmet. And actually, in a lot of ways, it's smaller than what I'm building myself. So I think this is going to be a superior solution. Now, again, this is a $1,000, $1,200 solution versus the $200 solution that I was working with. But if I break a couple more, then it's not really going to matter how much the cheaper solution was going to be. This is obviously a more robust solution. It's a commercial product. Not only do I have, it's been built to be used. It's obviously a VR HUD set. And so I'm looking forward to giving it a shot. Plus, this one breaks down really well. They've got teardown videos of it. You see it has this plastic thing across the front. I can take that off, which frees up even more depth in the helmet. So this is probably what I'm going to end up going with. I hate abandoning something I've spent so much time designing, but sometimes you have to leave stuff on the design floor just because there are better solutions out there. All right. A little bit about the software. I wanted to tell you what's running on this in case you wanted to give it a shot yourself. Again, all of this is open source. If you go to GitHub, I've got a link here. You can write it down. This is all open source software. It's all written in C, C++. It currently runs on the NVIDIA version of Linux, but I actually plan on making a Yocto installation. If you're familiar with that is where you build your own Linux to run on something. I plan on building a from-scratch version of Yocto to slim this down. It doesn't really need it, but it would make it a lot more kind of productized where someone could literally take an SD card or something and stick it in there, and that would be your operating system. Again, it's all C, C++. The video pipelines, everything you're looking at with everything that you're looking at with the video is running through GStreamer, which is a really nice way to process graphics. It made my life a lot easier. Plus, it made it really easy to port to other platforms. When I wanted to port it to Raspberry Pi, I was able to use the Raspberry Pi GStreamer plugins. I didn't have to make any changes to my code. I just had to figure out the new GStreamer pipeline for the Raspberry Pi, and I got it working. So again, the original version had the real-time object detection with the NVIDIA inference libraries and the TensorRT. It's currently disabled. I actually plan on rewriting the object detection here because the version I had originally was a little quirky. It worked, and that was the point. I showed that you could do it real time and that it was functional, but I didn't love it, how it was implemented. And like I said, it also has a lot of the enhancements, text-to-speech, automatic speech recognition. And let's go back here real quick. One thing I didn't mention a minute ago, these have eye tracking built in, which was very high on my list of things I wanted support for, because if I can track the eyes in the helmet, I can make UI elements on the HUD that actually do things based upon whether you're looking at them or not. I can do the object detection based upon what are you looking at, not just what's on the screen. But if I want to look at something and go, what is that? I'll be able to do that with the eye tracking. Eye tracking was something I played with a little bit with my own hardware, but This is better because they've got the eye tracking sensors down to like the size of a gram of rice. So again, that idea of a commercial product being able to do things that I just don't have access to from the hardware standpoint. All right, again, some of the libraries I use, I like to call these out because this is what I built on top of. So these are the open source projects I use. Simple direct media layer is what all the 2D graphics are going through. Again, I mentioned GStreamer, using Piper for all the speech synthesis. Piper is really nice. Piper works on multiple platforms. It has a lot of different voices. So if you don't want the Scottish voice, you can choose an American voice, or they've got a whole stack of different voices, male, female, whatever you're looking for. And that can just be swapped out. So if you get this software, you want to try it out for yourself, you can just grab a different speech synthesis pack, you drop it in, and it just works. Llama CPP is what I'm using for the local large language model. That's the inference engine that runs on the backside. Again, I originally used Gemma. I think I'm running Quinn on here now. I go back and forth just depending on what's testing better at the time. Then I use something called Mosquito, which is the MQTT name, and that's how everything communicates with each other. The battery management talks to the HUD, which talks to the AI assistant, and they all intercommunicate. And what's great is if something were to die, if for some reason battery management went down or the AI assistant goes down, it doesn't bring down the HUD. Because early on, and I'll tell you a lot of what I'm showing you here, a lot of what I've integrated in here is because I've walked around in this thing for a few years. And I know the problems that you run into. And losing vision when you're walking around a con is a bad feeling because you can't see anything. There's no pass through here. So, yeah. Again, that's an upgrade I want. One of the things I'd love to have in here, or in a future version of this helmet, maybe it's not even Iron Man, is the ability to see through the display. But again, I'm ending up with the problem of I'm not commercial. I can't just call people up and say, can you send me a transparent LCD display? And you find that those just are not readily available on the market for people to order and use. A little bit about the experience of wearing it. Video responsiveness, the video processing time is under 20 milliseconds per frame. The end-to-end processing time you can see here is about 80 milliseconds. But that has as much to do with the cameras and the display as it does with the software. So if I had better hardware, the software already has support for it. So again, if it's only taking me 20 milliseconds to process the frame, that means that I've got about 60 milliseconds somewhere else in the hardware chain that I need to work through. Again, I'm hoping the new, if I go with the new VR headset, that thing runs at 90 frames per second, and I'm hoping that gives me a better experience. Again, it's a full experience. I can report it straight to disk. The entire thing I've watched back when I walk around the con. It's really cool that I can record the experience and then play back the experience. I even had a friend of mine with the early versions of the recordings that I took. He put it inside of his Oculus and played back the video, and he could actually, experience kind of what it was like to be at the con just by playing that back. It does full live streaming, like I said, to YouTube or to local systems, being RTSP or UDP. These are, we've already talked about some of the enhancements. Here's all the crazy acronyms I've come up with for everything, because in the spirit of Tony Stark, everything should be an acronym. Aura is the advanced utility for reliable acquisition. We've got Dawn, which is the AI assistant. Digital assistant for wearable neural networks. I just changed that one. The end didn't work for me, so I changed it to something else. Mirage, multiple input reconnaissance and guidance environment. That's the heads-up display. And then Spark, the sensor-based positioning and actuation, repulsor kinetics. So that's like the hands. I've actually got repulsors that are wirelessly connected to everything. So where can you find a little bit about this? Again, open source, OASIS Project. I want to empower the community to take this and run with it, although I'm starting to learn that the bar is a little high for people to just take it and run with it. So I do hope that eventually someone joins me on this journey and we can get further together. All right, release the source and tell no one. I did that early on, but now it's all, everyone should have access to this. There's the GitHub link, and there's the website. I don't update I code faster than I can update the documentation, so the documentation will probably always be a little bit behind, but I do every now and then go in there and push updates, and then you'll have the updates. All right, and there's the rest of the place that you can find me. And now we have time for a little bit more of a demo and some questions. So let me finish up the demo stuff first. And I'll put back up this screen if you want to get that later. All right, so let me show you one other thing. Let's go switch over. You notice I've got these nice transitions here, which are programmable. You can set these up. I want to mention that the entire HUD is actually programmable. It just uses a configuration file. You can put, I want text here, I want an image here, here's the graphic, I want this cool, the reticle that's in the middle, I want it here. So all of it's configurable via the configuration file without you having to do any code. You say, here's the pixels, and this is where I want to go. Let's switch back over to this one. And and again, this is a live demo. Let's see how it goes. So around the front of this stage, I have various pieces that will eventually end up in my armor components. The entire suit will be wireless. So I'm not running a lot of Iron Man suits you may have seen. You'll have one battery pack, and then they run wires down the arms, and they have wires down the legs, and so you're trying to light everything up. It produces lots of points of failure. Obviously, if you pull something, if something gets disconnected, all of a sudden now your arc reactor is not working, your lights, all of that doesn't work. So I wanted to go completely autonomous, and so that one over there, you see the light just came on, and it should.
Bicep trait connected.
So the bicep, which is that one over there, just connected wirelessly to the suit. I now have access to its temperature and to its voltage. So not only do I have access to find out oh, it is connected now, it is working properly, but I know how long it's going to work for because the voltage is being transmitted directly to the suit. And there's another one. And then that will, which one was that? Should have been another light came on.
Bicep left connected.
There we go. And then we have another one that will just go on.
Thigh left connected.
And then the final one.
Thigh right connected.
There we go. So this one's actually one of the easier things I've done. So I've got these little custom boards built on other ESP32s, and this is how big it is. So the brains of this is this little piece here. It has a temperature and humidity sensor on it, and it speaks a special ESP32 wireless protocol over to here. I've done a lot of testing on this wireless. Originally, I was using Wi-Fi for everything, but Wi-Fi is garbage if you're at a convention, right? So I needed something that you have a limited number of bands here in the United States that you can use for wireless, and so they have a technology on these ESP32s called ESP Now. It uses the Wi-Fi stack, but it's a very small portion of it. It uses very small data packets, and it's speaking its own language that's not interfering with the Wi-Fi, and so you don't have to have the full Wi-Fi negotiation and everything. And so this is the only way I found, and I've carried this around. I was at MomoCon, I had them in my pockets, and I carried it around, and I had this test script running, and I wanted to know how many packets did I lose. It's super reliable, so I recommend this for anything you're doing cosplay. And I've seen other cosplayers using it now. That it's really good if you have a button you want to build because you want to be able to turn something on and off. It's really good for anything, and that again. Use your AI assistants if you're not familiar with this. You want to learn how to code it, or you want samples of it. ChatGPT is pretty good at giving samples. And again, this part of it is just so I can turn various parts on and off if I'm resting and I don't want to power down the suit. This is off-the-shelf RF radio frequency, and that's this little component up here. And I've got 4 channels, A, B, C, D. And so basically, and I can buy multiples of these sets. They all speak the same RF. And so if I have 2 sets of them, then I'll have 2 on each. I'll have 2 A's, 2 B's, 2 C's, 2 D's. and I can turn off the armor at any point. Initially, I'm using the little fob that it comes with, but since it's just RF, you could actually just take this, you could wire it directly into the other electronics so that you don't have to use the fob, or you could probably sniff this RF and figure out what the communication is and then build that into some other RF transmitter that you build into your suit. That's the plan. So, let me see. Oh, I wanted to talk about the board here real quick. Let's switch over to, you're not going to be able to see it because I have cooling over here. All right, so everybody sees what's on the table here? All right, so this is a custom mount, and this fits inside the back of my armor. So this is the back armor plate that goes right here between my shoulder blades, and I designed the mount to be able to screw directly to that plate, and it's pretty much the same size as that plate. It's got this mount on it, so this is a custom cooling solution. It actually has a passive cooler on the processor, and now it's blowing across it instead of over it, because if I were to put it up against my back, it can't suck in air. And so this is the cross ventilation over it instead. So all of that's custom mounted. The board underneath it is not the standard board either. I went with a carrier board, as they call it for the Jetson. It's a carrier board for the little module. And that is one by Arc Electronics. It is designed for drones. It's about the smallest one that I could find that had all of the features I needed. But they were really nice to work with me. They sent me my first one as a sample, and it's been a fantastic board. It's also really nice because it's designed for drones. It has like locking connectors in it, which is really nice that since you're wearing something, you have to think about like, are these things going to come unplugged while I'm using it? Anyway, so that is with all the new hardware. So Crashworks, I work with these guys all the time. They're great people. And they always like to send me samples to give away. So I'm going to give away a few of these samples. The samples that Crashworks has provided me today, it comes with what they call the Penelope board, which keeps your USB battery pack alive so that it doesn't go to sleep, as well as an Alicia board, which is what talks to, you can use these for either the helmets and motorizing the helmets. You can also use these for motorizing like your back flaps of your suit, that kind of thing. All right, so check out Crashworks. You can get Crashworks off of eBay is where they usually sell their stuff too. So I hope, I appreciate Crashworks providing me some samples to give out there. If you want some swag, they've got some stickers over here as well as some of my stickers. And I'm gonna go ahead and open this up. Questions, we got a few minutes. Yeah.
The main question I have is, you listed a bunch of things that you do for the slides. How much time do you think you spend on this a week?
Oh, it varies. It goes up and down quite a bit. So like the past month, I don't think I've gone to bed before 3. But that's con crunch. I do that to myself every year. I mean, normally I would spend, maybe a couple hours a night, but not every night, on it. So it's difficult to say how many hours. I mean, it is actually getting a little difficult to keep up with the code at this point. I have a lot of code bases. I've got like 4 or 5 different code bases at this point. What running on the helmet, what I did for battery management, the AI assistant, and I'm jumping around these code bases all the time. And so there's quite a bit of code to keep up with at this point. I've a couple of times lost some code because I've been working on multiple systems, and I'm like, I forgot to push that code up before I did something. And so, being a one-man development team on this, and having a day job where I'm writing different code, it's pretty time-consuming, and it's a big project.
I was wondering, to solve the mechanical problem of having wires everywhere, if you distributed your batteries
Yes.
different places.
Mm-hmm. Each one of these has its own little, what's this, 1100 milliamp light hood.
Okay, and you're keeping track of it wirelessly.
Yes.
And is that in the net battery power, does it tend to increase the amount of battery power you have?
Yes, but not that much. And so what I mean by that is, so now everything has its own battery. So now I have, however many batteries around the suit, and they're not all draining off of the central battery. But these things sip so much less power than this does. Percentage-wise, you wouldn't notice the difference if those were all draining off of this battery. It wouldn't pull that much comparatively.
Well, wait a minute, so, but each section is an independent battery?
Yes.
It doesn't, how would it pull off from central?
Oh, I'm saying, so the option is it's
Oh.
either distributed batteries or pulling off the
wires
central.
from the central.
Right. And so typically, like if they were pulling off the central battery, again, they're pulling so much less than that main computer does,
Yeah.
it would be minimal impact to the lifespan of the battery.
Okay.
But it does, of course, increase. And I chose the size of these batteries in relation to this one. I know how much that these drain. And so these little 1100 milliamp hour batteries will last about as long as this one will with the duties that they're doing.
Our batteries getting any longer?
Yeah. In fact, these Samsung batteries that I'm using here are really high capacity, but they're the same size as comparable ones. So these are standard. I forgot what these are called. These are they have a warranty on them, but anyway, they're a standard battery size. But like these are the 50. Yeah, these are 50. I forgot the rating, but they're 50. Where you get other ones that are 35 and things like that. So. Yeah, they're constantly, and these are, like I said, these are over an milliamp hour on these, or over an amp hour on those, so that's quite a bit. Anyone else? Yes.
Yeah, you mentioned ESP now, which is a fabulous protocol, has great range as well.
Yeah.
I have sort of a two-part question. Are you just doing one-way communication or the two-way? And then how do the peripherals, like the 4 pieces of armor, know about the suit? You just like hard code the MAC address, or give some kind of a?
No, it's a discovery system.
Okay.
So it is two-way. There's a negotiation that goes on. So it actually happens over broadcast. I don't have to pre-program the central computer to know about which armor components. The armor components broadcast to here, or actually, yeah. So they broadcast to it. They go, "Hi, I'm here." They negotiate that they're going to be up here. They tell it, "Hey, this is which armor component I am," and then that's how they negotiate. So if I want to add a new one, I don't have to say, "Oh, I'm adding this, recode this, upload this." I actually can just code the new item, give it an ID, and it uploads. So when it says, "I'm the thigh right," the suit didn't know the thigh right was going to come in. That was dynamic. Okay. The suit itself, because there's a graphic representation of it, I do have all of the different components that could be in the armor already pre-programmed into the HUD because of the fact there's a graphic that goes along with it. But there's no reason it would have to. If something joined up and said, "I'm your right pinky," I just don't have a graphic for it, but it should theoretically just work.
What if a second by right try to connect?
It will not let it. So there is mutual exclusion there where it goes, "I already have one of those. You can't connect." That was just a little bit for security as well, because then if someone were to be using my code and they got too close to you, and now your armor tries to interact, this would be a bad thing because they didn't know that they were supposed to, choose different addresses. I also have security. So I think I'm running that in this build because it's something you can turn on and off. But I also have a fixed security key that is shared between these devices and the armor. And so there is a fixed key that I changed just for that reason, just so that if there wasn't someone else next to me, that my security key is different than their security key, so they cannot interact. So security is built into this as well. Yes?
Why use the micro Wi-Fi thing and not just like Bluetooth or something?
I don't like Bluetooth.
Okay.
And I'll tell you why. Bluetooth requires pairing, right? Most of the time you have to pre-pair everything. There's some code that you have to write for the pairing. And that's the main reason, is that I didn't want to use something. Plus, again, with all of the background noise that's going on, everyone's got a bunch of Bluetooth devices. It's kind of a spectrum thing where I'm trying not to interfere with other things that are, going on. From that experience with the Wi-Fi, I did want to, let's try Bluetooth, and I bring it to a con and I try Bluetooth, and I find that Bluetooth is no better than anything else that I've used because of the noise in the 2.4 gigahertz range. I mean, ESP now, of course, is still using 2.4 gigahertz, but it's different. It's already taken into account the fact we need very small packets and things like that.
As far as the central controller
Mhm.
for the HUD and the rest of the armor, physically, is that it? Like what you've got on the screen right now, is that everything?
Meaning, like, what
Like,
you?
is that all of the hardware that's in your armor?
Yeah, just this computer. So, and again, it all fits on this plate. Everything that I need to run the suit fits on this plate. And it did require a custom, like I said, this is the smallest board I could get my hands on that had all of the input output I needed. It has these little boards. Let me switch. Is that what's still in there? Okay. It still has these boards here. These are just little carrier boards that actually convert the camera signals, which are CSI, MIPI, these little wires here. It converts that into HDMI cabling, not signaling, cabling, so that I can run that down to the helmet. Because the helmet is still wired due to the bandwidth that's required to transmit 4K signals and the cameras back and forth. And so there's still USB that goes to the helmet. There is still the one HDMI cable for each camera. And then there is the display port or HDMI that you use for the display input. So 4 cables total. Yeah. Okay. Any more? Yeah.
Yeah, like, what kind of overhead does that have for like installing more components? The thing that I want to build is basically a Modem, articulating wings, armor suits, and the gun,
Yeah.
saber, stuff like that. Does it have a lot of like memory overhead or upgradable memory?
So a lot of the stuff now that it's running, right? So I've pretty much maxed out the memory in terms, not completely, but it's running the large language model, which takes about 4 gig. It's then running all the small machine learning things for like voice and AI and all that stuff. And so we're into the upper limits of what the thing can do. But it's not much to add a new graphic for this or a signal for a separate, for wings or whatever you want to do, that kind of thing. So adding little things like just another feature is very small overhead compared to what's already running on here. So I plan on doing back flaps, for example, on the back of my armor. And so that will not take there's plenty of overhead with things like that. Plus, I plan on doing a lot of it wirelessly, right? I'm going to put a separate controller like these little guys to do that, and then they will talk wirelessly to the suit. And so I won't have to have it doing the processing. I like to distribute things. I like to make the processing work on other chips and then do it with communication, rather than worrying about trying to make one computer do everything. Initially, I was going to have the GPS and everything talking directly to here. I'm like, it's so much more efficient to let a microcontroller handle sensor readings and things like that than it is to have a big like Linux system do it. It's a better way of doing it. So, I'm out of time. If you guys want to talk as I'm cleaning up, that's fine, but I don't want to cut into anyone else's time. Thank you all. Please remember to rate. Please remember to give to the charity. Thank you very much.